Today is the last day in section 4.4, and again we're going to be using the skill that we learned in the prior video of reference angles, and now I'm going to show you how to use that skill. So the directions say use reference angles to find the exact value. So for this example, I'm giving you sine of 135 degrees. So we're going to use the idea of reference angles and then kind of pair it up with the idea of which trig functions are positive in which quadrants to find the exact value. So again, the goal is that we're slowly phasing out the unit circle and just having the first, the coordinates in quadrant 1 memorized, and then we go from there. So if I'm dealing with 135 degrees, we know that falls in quadrant 2. So 135 is right here. It's really sloppy. So this is 135, and the goal of the reference angle is to find the distance from the terminal side to the x-axis. So the difference between the two would be 45 degrees. And since we're dealing with 45 degrees, I know the coordinate is root 2 over 2 and root 2 over 2. So now that we have the coordinate identified, the last thing we need to figure out is the sign, meaning is it going to be positive or negative. So since I'm in quadrant 2, remember this whole all surfers tan constantly. So quadrant 2 means that sine is positive. So when I go to find sine, I know sine is y over r. So looking at this, here's x, here's y. So my y value is root 2 over 2, and since it's positive in quadrant 2, I leave it positive, and the answer is root 2 over 2. So let's try another one like that. So I want you to find cosine of 4 pi over 3. And again, all of these values come from the unit circle. It's just we don't want to memorize every single value. It's a lot of information. So instead we learn about these techniques and tools to help us along the way. So 4 pi over 3. So I know here this is 0, and I know this is 3 pi over 3. And I know this is 1.5 over 3. So this is 4.5 down here. And I need to figure out where the 4 pi over 3 falls. So that would be closest to there. So my distance from the x-axis, so from there to there, would be 1 pi over 3. So that's my reference angle. Because this is my reference angle, now I think of the coordinate. So pi over 3 has the coordinate 1/2 and root 3 over 2. My angle is in quadrant 3. Okay, so since this arrow falls in quadrant 3, I'm here. So the only trig function that's positive in quadrant 3 is tangent, which means sine and cosine are negative. So Q3 means cosine is negative. Okay, and then the last part of it is, well, cosine is x over r. The x part of the coordinate is 1/2. R is always 1 because it's from the unit circle. So my answer is 1/2, but I have to go back to this idea that it's negative. So that's my answer. The other way to go about this problem is, as soon as you saw that this was in the third quadrant, you could go to your coordinate and say, well, because it's in quadrant 3, x and y are both negative. And then you kind of can eliminate this step over here if you'd rather do it that way. So whichever way makes more sense to you. So let's try another one. So tangent is 14 pi over 3, and they want you to find the exact value. So right off the bat, you should realize that this value is way too large. So we need to find a coterminal angle first. So 14 pi over 3, we're going to take out that 2 pi, and again get common denominator. So I'm subtracting a 14 pi over 3 minus 6 pi over 3. So when I subtract it, I get 8 pi over 3. Notice still too large. The cutoff would be 6 pi over 3. I'm above it, so I'm going to subtract 6 pi over 3 again. So now I'm at 2 pi over 3. So this is my reference angle. So now I need to find out where that falls. So I know this is 0. I know this is 3 pi over 3. This is 1.5 pi over 3. So 2 pi over 3 would fall right here. So the distance between these two would be 1 pi over 3. And we just used this in the last one. The coordinate is 1/2 root 3 over 2. My angle is falling in the quadrant 2. So tangent is negative in quadrant 2. And tangent is y over x. So I need to take this root 3 over 2 and divide it by 1/2. Keep change flip. I have root 3 over 2 times 2 over 1. 2's crossed out. I get the square root of 3, but again, we know tangent's negative, so my final answer is negative square root of 3. And again, another way you could have gone about this is as soon as you saw your angle was in quadrant 2, you could have gone to the coordinate and said, well, I know x's are negative in quadrant 2 and y's are positive. And then you would not have to worry about that last step that I talked about. Okay, so that's all for today. We'll pick up with this. Actually, no, you know what? I'm going to do one more example. So one more problem just because it kind of ties everything in together. So here we have secant of a negative 17 pi over 4. So notice the angle's negative, so we got to get it up into the positives. So first thing that we're going to do is add 2 pi. Put this over 1 times by the 4. So I'm adding 8 pi over 4. So when I add these the first time around, I get negative 9 pi over 4. Notice still in the negative, so no good. I'm going to add 8 pi over 4 again. I get negative 1 pi over 4, still in the negatives, so I need to add one more time. So my reference angle is 7 pi over 4. So we have to do all that work just to figure out where the angle is going to fall. So I know this is 0, this is 4 pi over 4, so that's 2 pi over 4. So down here is 6 pi over 4. This is 8 pi over 4 next to the 0. So my 7 pi over 4 is going to fall right in the middle, which means my reference angle, so the distance between 7 pi over 4 and 8 pi over 4, would be 1 pi over 4. And the coordinate for that is root 2 over 2, root 2 over 2. And secant is r over x. So my r is 1, because it's a unit circle. So 1 over my x value of root 2 over 2. Keep change flip. And then we have to rationalize. So that means multiply top and bottom by root 2. So I get 2 root 2 over 2. 2's cancel. I'm at the square root of 2. Last thing we have to talk about is quadrant 4. So I'm in quadrant 4. And we know that cosine is positive in quadrant 4, which means secant is positive in quadrant 4. So I don't need to change that. So that's our final answer. Again, the other way you could have gone about this is in quadrant 2, x's are positive, y's are negative. Notice I didn't even use the y value in my calculations, so that's why the answer is still positive. All right, now that's really all for today.